Hello and welcome back to the channel. Today I'm going to do something still involving solar panels. So this is a bit of a third part in a series of solar panels that I've been working on. So far we've looked at the various different solar panels and how I've used those to charge up various radios and other battery packs. Looking at lower voltage though, aren't we? We're looking at kind of like 5-6 volts panels that will charge up portable power banks like these. On a similar kind of road to what this Solio panel is here, where you have the output which will give you anywhere between 5 and 12 volts. So we've actually made a usable panel from a 6-volt panel here, just using a little voltage regulator circuit that we talked about in the last video, which will make sure that you only get 5 volts out of this. So no matter what voltage this is generating, and you're talking about 6 and 7 volts open circuit, that's too much for an iPhone or for a smartphone. It just won't work, and you'll damage any ordinary phones as well. So this regulator ensures that you only get a maximum of 5 volts, and I think this will give up to 2 amps as well, providing the panel will. Now in this case it won't, but it safeguards your equipment. So what happens if we want to go the other way around? Supposing we want to be able to get a 12 volt supply from a 5 volts power bank. Well, like I explained with the Solio, you can get step up DC to DC inverters, which will transform the 5 volt output up to a usable 12 volts. Now by doing that you are going to lose some of the current. However, there's still enough current there to charge up a basic device, whether it's an old mobile phone or whether it's a sat-nav or a portable lamp. You'll still get enough current to do that. So that's what we're going to look at doing today. So using one of these simple circuits, and I shall give you a close-up of that on the internet, which I bought from eBay. These are about just over £1 each. I paid about £1.04 each for these. It's actually a 2 amp DC to DC boost step up adjustable volt converter. So you can plug in anywhere between 3 and 24 volts and it'll give you anywhere between 5 and 28 volts output. And it's variable, so just by using a very fine screwdriver, that screw up there, you can just adjust the voltage to what you require. Very simple to set up, and that's what we're going to do now. So 3 basic components are required for this then. So first of all, we need to have a 12 volt outlet. Now this is just a simple 12 volt cigarette lighter socket with a stretch of wire attached to it. This is a USB plug. This is what's going to be plugged into the USB supply, or the 5 volt supply that we need. And then that's the positive and negative coming out. And then this is the circuit. Very simple, very small. I don't have a project case for this to go into just at the moment, so I'm not going to do a final job on this. It's going to be a bit of a floating circuit. But quite simply, on the left hand side we've got the positive in and the negative in. Then on the right hand side we have the positive out and the negative out. So it couldn't really be simpler. So first things first, we're going to get this cable, which is the USB, and I'm just going to tin these wires. Like so. Just going to cut these to size. Okay. And then we're going to solder positive to the top, and the negative to the bottom. There we go. And then for the output, making sure we get the polarity right. Now I already know that that striped one is the negative. So negative there. And the positive there. And there we have it. This is going to be plugged into a power bank or a solar panel. That's going to give me the 12 volt output. What we need to do now though, before we start plugging things in, we need to check the voltage, because obviously these aren't currently set to any specific voltage. So we need to make sure we do that. So, plug the meter. Negative onto there. And the positive onto there. Plug that in and turn it on. What do we get? So that's an interesting one then. There we go. So that's an interesting one then, isn't it? So in fact, it always pays to test your wiring. So on this moulded plug here, I assumed that the pink was going to be positive and the white was negative. But in reality, testing it, it's the other way around. White is positive, giving me 5.26 volts out, and the pink is the negative. So there you go. Always pays to double check, doesn't it? Right, back onto the circuit then. Let's try this again. Get this soldered back into place. Right, are we ready to try this again then? So, again, let's connect, assuming we've not damaged the circuit. Let's check to see what we've got on the out. Oh, okay, we're quite close then. So you can see on the meter, it's registering 12.9 volts. Now, if I alter this, I can turn it clockwise, and it reduces it. It takes it straight down, look, as you can see. Let's go steady as we are. Now sometimes, quite often, you'll find that the open voltage is different than the voltage under load. I'm going to leave it at just hovering slightly over 12 volts there for the moment, and we're going to plug in a device and we're going to see how that performs. Right, so I'm going to use this old Nokia handset. Okay, so this is a Nokia charger. It's for the 8310. Not quite the same phone, but it fits, so hopefully that will do the job. And we're going to see whether we can charge this up from a 5 volt supply. So let's plug that in. Right, there's a red LED that's come onto the cigarette lighter adapter, onto the plug. Oh, and look, there we are, look. Can you see that's charging? Can you see that there from that angle? I'm not sure whether you can or not. We've got the battery bars climbing up there. So that's powering nicely. Now the voltage, as you can see, has now gone down to 6.8 volts. So obviously this is a circuit that's now got a load on. So what we can do, we can actually adjust this. If I turn it anti-clockwise, right, that's not making any difference there. So this is obviously down to the current. So this is pulling quite a lot of current out of this circuit compared to what's going in. So that's not going to give us any more than that. But that's absolutely fine. That doesn't matter. If I unplug that, we're down to 12.18 volts. That's absolutely fine. I'm happy to leave it at that. Plug it back into charge. It's taking quite a bit out. So this is very, very inefficient though, if you think about it, because what we have a circuit here. There's potentially, especially from a battery bank, it's going to have, let's just turn that off, it's distracting me. The circuit that's going to have, you know, maybe 5 volts or 3.7 volts, which is being stepped up to 5 volts, which is then being stepped up to 12 volts. Once we've got the 12 volts, it's then being stepped down in this plug down to the required voltage for the handset. So you're losing a lot of energy through all those transformers. So it's very, very inefficient really. However, it does do the job. So if I unplug this from there, that effectively can be plugged into anything at all. I wonder whether we can get any power from this power bank at all, or is it completely... Yeah, it's completely flat, that power bank is. So yeah, so even if it was to plug that into a solar panel, that would still have the same effect. Just a quick afterthought here. I've just come back outside. As you can see, it is very overcast. There's no sun out today. But using this 21 watt panel that I showed you before in the video, 5 volt output. I have 2 USB outs. I've got one charging this lantern at the moment, and the circuit that I've just demonstrated is plugged in to my 12 volts, and you can see on the screen, hopefully you can see that, it is charging up nicely. So that's charging from a 12 volt supply, initially from a 5 volts, just from this small little solar panel set here. And this lantern's also charging, and you can see an LED. Hopefully you can see the LED flashing in there. All charging nicely. Very happy with that. I'm very happy. That's working nicely. Isn't it great what you can do with solar? So going camping, which we are in a few weeks' time, even if it's not sunny, this panel performs well enough to give me the power that I need to charge a phone and to charge a lantern. Now obviously I won't be charging this phone because I don't use this phone anymore, and I don't really have anything that requires 12 volts that I necessarily carry around with me. However, you never know, there's always times on there where you need a slightly high voltage output for a radio or something. Anyway, I just wanted to quickly show you that. Hope that helps put things into perspective a little bit for you. So, for a portable circuit, for a portable, very handy, relatively smallish device, bearing in mind that will be in a protective box very soon when I get one, that's a useful addition to have to go with your portable solar power banks and your panels and any radio equipment to carry. Let's not forget that this does draw quite a bit of current with it being an older phone, and if we replace that with a portable radio like a typical Baofeng UV5R for a 12 volt supply to give that charge from solar, what better solution? We could even have it plugged into here. That'll be interesting to see because this is very low current. It'll be interesting to see how well that would perform as well in the sun. Unfortunately today is a very, very cloudy, overcast day, so I can't demonstrate that just at the moment. But there you go, just wanted to show you that quick principle there. So I think that really concludes what I wanted to show you. With everything now that we have here, I've pretty much replaced the Solio with the capabilities that this had. I'll be honest, there will always be a place in my heart for the Solio. This has been on many holidays with me. It's charged up many a phone, an iPad, not an iPad, sorry, like little iPod shuffles and music, MP3 players. It's charged, it's done brilliant work. I've even had the sucker fastened onto that with it fastened onto an aeroplane window, which caused a bit of alarm to the stewardess who asked me to remove it because it looked a bit scary to people who didn't know what it was. Maybe they thought it was some sort of explosive device, I don't know. But it certainly performed brilliantly for me back in the day. Like I said before, it's just not really that compatible with modern day technology through to the extra current that's required for things. But it's certainly been brilliant, and very fond memories of using that. But as things progress, as technology progresses and we use more and more power, we have to upgrade things, don't we? And we have to go to bigger panels. I think the next thing I'm going to do is to smarten this up, get this one smartened up, tidied up a bit, make a nice little leather case for this, and have this as a spare portable charger as well to go alongside the kits that I have. Right, okay, I'll put in the link below for the boosters and the DC-DC converters, and I hope you found this series of videos fairly interesting. Please leave any comments down below, and I'll catch you in the next video. See you soon.